Hey everybody, this is Mr. McKee again with SEC 210. Today I'm going to be going over Lab 4.5.4, which is navigating the Linux file system and permission settings. Alright, there are about 18 questions to answer, unless I missed some. So you go ahead and answer those. Everybody, for the most part, looks like they're doing that good. Make sure you put the answers in a different color, and I've marked, where all the answers are supposed to be located. Alright, so we're going to be exploring the file system in Linux, file permissions, and symbolic links and other special file types. Alright, so we're using the CBROPS, VM. Alright, exploring file systems in Linux. The Linux file system is one of the most popular features. While Linux supports many different types of file systems, this lab focuses on the ext family, one of the most common file systems found in Linux. Access command line, which I already have up. Alright. Display the file systems currently mounted. Now, I've been playing around with this, so the mounts might be a little messed up, but I'll let you know. Alright, file systems must be mounted before they can be accessed and used. In computing, mounting a file system means to make it accessible to the operating system. Mounting a file system is the process of linking the physical partition on the block device, which is the hard drive, the solid-state drive, or the pen drive, USB drive, etc., to a directory through which the entire file system can be accessed. Because the aforementioned directory becomes the root of the newly mounted file system, it is also known as the mounting point, and we're going to be doing that. Alright, so use the lsblock command, lsblk. Alright, notice we have actually 3 disks, which this is like a CD player or DVD player. This is one disk, SDA, and this is SDB. And notice each of those have one partition. Alright, you have a 10 gig drive, which is SDA, and a 1 gig drive. Alright. So the output above shows that the CBROPS Workstation VM has 3 block devices installed, SRO, SDA, and SDB. The tree layout output also shows partitions under SDA and SDB, which I just showed you. Conventionally, dev SDX is used by Linux to represent hard drives. Alright, so X being not literally SDX, but SD and then whatever drive it is, A, B, C, etc. Alright, with the trailing number representing the partition number inside that device. Alright, so like that, SDA, etc. Alright, computers with multiple hard drives would likely display more dev SDX devices. If Linux was running on a computer with 4 hard drives, for example, they would show them as SDA, SDB, SDC, and SDD. Alright, the output implies that SDA and SDB are hard drives, each one containing a single partition. The output also shows that SDA is a 10 gig drive, while SDB is a 1 gig drive. Alright, so we see that. No problem so far. Alright, Linux often displays USB flash drives as dev SDX as well, depending on their firmware type. Use the mount command to display more detailed information on the currently mounted file systems in the CBROPS Workstation virtual machine. So if we type in mount, alright, that shows us a whole bunch of junk, which is really hard to read. Alright, many of the file systems above are out of the scope of this course and irrelevant to the lab. Let's focus on the root file system, the file system stored in dev SDA1. The root file system is where the Linux operating system itself is stored. All the programs, tools, config files are stored in the root file system by default. Run the mount command again, but this time, and I'm going to do Control-C to break out of that. This time use the pipe to send the output of mount to grep to filter the output and display only the root file system. Alright, so I can use my up arrow to go back to mount. Everybody should have used pipe before, but it's a shift and the backslash. I don't know why I couldn't think of that. Alright, grep SDA1. Alright, that shows only the one hard drive. Alright, notice, well actually I say hard drive, the hard drive, and this is the one partition. and it's formatted with ext4. Alright, so in the filtered output above, mount shows that the root file system is located in the first partition of the SDA block device, dev SDA1. We know this is the root file system because the mounted point used, which right here. Alright, the slash, // The output also tells us the type of formatting used in the partition. ext4 in this case. The information in between the parentheses relates to the partition mounting options. Alright, so issue the following two commands below on the CBROPS workstation VM. Alright, so we're going to change directory to root, folder, list, long form. Alright, what is the meaning of this output? You can explain what it's showing us. Alright, where are the listed files physically stored? Alright, I'll let you guys answer that. Alright, why is dev SDB1 not shown in the output above? And when they're talking about that, they're talking about this right here. Alright, if you think about it, if it's not finding it, it told you something up here that has to be done first and able to, for Linux to be able to see that drive. Alright, and we'll get, if you don't understand it now, you'll run into it further down the line in here. Alright, so manually mounting and unmounting file systems. The mount command can also be used to mount and unmount file systems. As seen in step 1, the CBROPS workstation VM has two hard drives installed. The first one was recognized by the kernel as dev SDA, while the second was recognized as dev SDB. Before a block device can be mounted, it must have a mounting point. Alright, so we're going to set up a mounting point as the second drive using the second drive directory. So we're going to change directory. Alright, and if you do pwd, we're in the home analyst directory. Alright, so list, long form. Alright, notice there is a second drive folder in there. And it says that the second drive folder does not exist. You're going to make the directory because it's empty. But we're not going to do that. Alright, so let's do a list, long form, second drive. Notice there's no files in there. Total 0. Alright, use the mount command to mount dev SDB1 on the newly created second drive directory. The syntax to mount is mount options, device to be mounted, and mounting point. So we've got to do superuser do mount to dev or mount dev SDB1 to / second drive. Alright, we have to put our password in. Alright, which is CBROPS. Alright, no errors, so it was successful. Now that the dev SDB1 has been mounted on the home analyst second drive directory, use the list long form second drive. Alright, now it shows it's able to find that or see those files. 20 files, 20 files in there. Alright. Why is the directory no longer empty? Well, it's made an insertion point. Alright, let's see. Or a mounting point. Alright. Where are the listed files physically stored? Now you could do pwd. Alright. Or you can do change directory second. Now let's do list L. Change directory second. List. All right. All right. So the listed files are physically stored where? They're physically stored in the dev SDB1 drive. All right. Issue the mount command with no options again to display detailed information about dev SDB1. As before, use the grep command to display only the dev SDX file system. So if we do mount, I click in here, mount, type, grep, dev SD. All right. Notice this, the insertion point is on the root, and the insertion point of SDB1 is on home analyst second drive. All right. All right, Linux file systems have built-in features to control the ability of the users to view, change, navigate, and execute the contents of the file system. Essentially, each file in file systems carries its own set of permissions, always carrying a set of definitions about what users and groups can do with the file. All right. Navigate to Home Analyst, Lab, Support Files, Scripts. All right, PWD. All right, notice we're in there. So we're going to Analyst. Wonder if I can do this. Lab, Support Files, Scripts. All right, see what I'm doing? I'm doing, since I'm in one child folder of Analyst, which is the second drive. If I do CD to backup, and then a / and then if I type in lab and hit tab, it autofills in lab support files and scripts. So doing that, I don't have to back out and then go into that folder. All right, so if I do PWD now, home analyst, lab support files, scripts. That's just a shortcut. It's all about making it easier on yourself. All right, so display file permissions. We're looking at CBROPS.mn right there. I'm trying to highlight it, but it's tough. All right, consider the CBROPS.mn file as an example. Who is the owner of the file? How about the group? Well, it'd be right in here. All right, so looking at this, this is the owner and the group. All right. So who's the owner of the file? Analyst. How about the group? Analyst. All right. The permissions, let's see. The permissions for CBROPS.mn are -rw-r-r-r-. All right. What that means is the owner can read and write, but not execute. Notice how down here it has execute. I think this is a different type of file. Execute, the D is directory, but looking at CBROPS.mn, the owner can only read and write, the group can only read, and others can only read. All right. So let's see, I want to clear this. All right. So the touch command is very simple and useful. It allows for a quick creation of an empty text file. Use the command below to create an empty file in the mount directory. All right, so touch, mnt, my new file.txt. All right, touch, cannot touch, mount my new file.txt, permission denied. All right, why is this file not created? All right, has to do with permissions. All right. So list the permissions, ownership, and content of the mount directory and explain what happened. So if we do, all right, let's do a list. Let's see. Oh, you know what? I don't know what I'm thinking about doing. Let's see. I'm going to do CD. So we're in scripts. Let's see. Look at a home directory list. Let's do CD list the roots, and that thing is in MNT. All right. Notice the directory for mount. Read, write, execute. Roots the owner and roots the group. So everybody else can only execute or read, or I'm sorry, can only execute in that folder. That's why we can't, it won't work. Alright, so let's see what we got here. So with the addition of the -D option, it lists the permissions. Oh, I didn't even look down there to see that. So let's go back to home directory. Now this home and list. Alright, if I do the list LD count, whoops, if I type it correctly, it works better. Alright, notice that was a shortcut for what I did, but there should be permissions. Alright, what can be done for the touch command shown above to be successful? Okay, so what I can do, I can either do super user sudo before the command, or I can change the permissions of that folder. Alright, so we're going to change permissions, it looks like. So the chmod command is used to change permissions of a file or directory. As before, mount the dev SDB1 permission partition on the, I think it means it should already be mounted. As before, mount the dev SDB1 partition on the home analyst second drive directory created earlier in lab. Alright, change the second drive directory and list all of its contents. Alright, so let's do CD second drive. Alright, list L. Alright. So what are the permissions for the my file.txt? Notice here, analyst is the owner, group is root, and probably what happened, I don't know, that shouldn't be, that should be root. Root should have your permissions, probably say root and root as a group, but we're going to roll on with it the way it is. Alright, so we got permissions, there's our permissions, and these permissions look a little different too. Yours might just be read and write. Read and write for the owner, read for the group, and then read for the all others. Alright, so let's see. So use the chmod command to change the permissions of myfile.txt. So we're going to use sudo chmod 665 myfile.txt. CyberOps. CyberOps. All right. So we do list. All right. Looks like for some reason this was already set. Maybe they made the OVA file. This is what it should be changed to. Because basically you're doing 665 for change mod. The R, let's see what it shows here. Where's the numbers? Read, write, execute. Read, write, execute. Because the way it should be, 6 in octal order, 110, it actually should be read, write is 6 because read is 4, I guess in octal. Write is 2, so that'd be 6. So 6 for these, and then read here is 4, and then X is 1. So 665, you're making the owner read write, the group read write, and the all others read or execute, but not write. That's how it works out. Alright, so we wanted to, what command would change the permissions of myfile.txt to RWX, 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 so granting any user in the system full access to the file. Alright. Yeah, see, going on here, they're changing the, that definitely shouldn't look like that. But this is why I'm going through this the first time, just to make sure everything works. Alright, so now it didn't tell us to do that, but if we did change mod 777, that'll give everybody permission to read, write, execute. Alright. So change own, use to change ownership of the file or directory, issue the command below to make root the owner of the myfile.txt. Root the owner. Alright, sudo, yeah, it's already set up like this, but change own analyst myfile.txt. Alright, and if we do list L, notice it's still like that. Alright, let's see. To change both the owner and the group to analyst at the same time, use the sudo change own analyst myfile.txt format. Now that the analyst is the file owner, try appending the word test to the end of myfile.txt. And what I want to do first, I'm going to cat my file. Alright, this is a file stored in the dev SDV1. Notice that even though this file has been sitting in this disk for a while, it could be accessed until this drive was properly mounted. And then test is the end. Yeah, see, this has already been done. So it looks like we need to, well, it's good practice to fix it. But see, if we did what it says, echo test append my file. Now we're going to have test twice. Alright, jump up arrow again. There we go. Alright, so that was already done, but that's fine. As long as you understand how to do it. Was this operation successful? You can explain if it's successful, but yes, it was. Alright. So directories and permissions. Similar to regular files, directories also carry permissions. Both files and directories have 9 bits for the permissions of the owner user, the group, and the others. Alright, where are we at? I think I just said that, but both files and directories have 9 bits for the permissions of the owner user, the group, and the others. There are also 3 more bits for special permissions: set UID, set GID, and sticky, which is beyond the scope of this lab. Change back to the home analyst lab support files directory and issue the ls-l command to list all the files with details. Alright, so cd tilde lab support files. Alright, so we're in lab support files, list L. Alright. So compare the permissions of the malware directory with the mininet services file. What is the difference between beginning part of the malware line and the mininet services line? Right, notice here got some differences. Well, this for one, malware is a directory. Permissions are the same. All right, but that's file, that's the directory. Where you see the D. All right. So the letter D at the beginning of the line indicates that the file type is a directory and not a file. Another difference between the file and directory permissions is the execution bit. If the file has its execution bit turned on, it means it can be executed by the system. Directories are different than files with the execution bit set. A file with execution bit set is an executable script or program. A directory with the execution bit set specifies whether a user can enter that directory. All right. So the change mode and change own commands work for directories in the same way they work for files. All right. Symbolic links and other special file types. You have now seen some of the different file types in Linux. The first character in each file listed in the ls-l command shows the file type. The 3 different types of files in Linux, including their subtypes and characters, are regular files, including readable files, text files, binary files, programs, and image files, and compressed files. Directory files, folders, special files including block files, files used to access physical hardware like mount points, to access hard drives, character device files, C files that provide a serial stream of input and output. TTY terminals are examples of this type of file, like your, well, I'm not going to get into networking, but yeah. Pipe files, a file used to pass information where the first bytes in are the first bytes out. This is also known as FIFO, first in, first out. Symbolic link files, files used to link to other files or directories. There are 2 types, symbolic and hard links. Socket files, these are used to pass information from application to application in order to communicate over a network. Examine file types. Alright, so let's see. Use the ls-l command to display the files in the home analyst folder. So if we did a cd tilde oh, it's not going to work. Let's see. It'll work like that. L. Alright. So notice all the directories, 2 files. Produce a listing of the dev directory. Scroll to the middle of the output and notice how the block files begin with B. List -L dev. Right, two out the middle. Alright, block files begin with the letter B, the character device files begin with the letter C, and symbolic links files begin with the L. Right there. Symbolic links, character device, and what was the other one? Block files, right there. Notice SDA, SDA1, SDB, SDB1. Alright, symbolic links in Linux are like shortcuts in Windows. There are two types of links in Linux: symbolic links and hard links. The difference between symbolic links and a hard link is that the symbolic link file points to a file name of another file, and the hard link file points to the contents of another file. Alright, create two files by using echo. And let's see, we are back. I'm going to clear this screen. Alright, so echo symbolic. Alright, file 1.txt. Alright, cat file 1.txt. Alright, so it says symbolic, and we're going to do a file 2 and have it say hard. Alright, and then if we do file 2, alright, so that's working. The ln-s to create a symbolic link to file 1.txt, and ln to create a hard link to file 2.txt. So -s file 1.txt file 1 symbolic. Where did I mess up? Oh, that's where I messed up. It's not going to list. It's going to ln. All right, there we go. All right, then ln. Let's go to this file 2.txt and make this file 2 hard. All right, list -L. All right, notice we have this symbolic link right there, and file 1.txt, file 2.hard link right there, and file 2.txt right there. All right, notice how the file 1 symbolic is a symbolic link with an L at the beginning of the line and a pointer. Notice the pointer right here, pointing to file 1.txt. The file 2 hard appears to be a regular file because it is in fact a regular file that happens to point to the same inode on the hard disk drive as file 2.txt. In other words, file 2 hard points to the same attributes and disk block location as file 2.txt. The number 2 in the 5th column of the listing for file 2 hard right there indicates that there are 2 file hard linked to the same inode. For a directory listing, the 5th column indicates the number of directories within the directory, including hidden folders. Alright. So change the names of the original files, file 1.txt and file 2.txt, and notice how this affects the linked files. new.txt, file1 new.txt, whoops, new. Alright, and up arrow file2.txt to file2 new. Alright, cat file one symbolic. Alright, so we can't find it because it's pointing to file1.txt. Alright, let's do cat file2 hard. Alright, notice it because it's actually there. Alright, notice how file1 symbolic is now a broken symbolic link because the name of the file has been pointed to file1.txt has changed, but the hard link file2 hard still works correctly because it points to the inode of file2.txt, and it's not its name, which is now file2 new.txt. Alright, and if we do a list tell, alright. What do you think would happen if file2 hard if you open the text editor and change the text in file2 new.txt? Alright, so well, we can do it. So what we can do is if we do a nano, well, I'll do it just like I can do it a different way, but if I do nano file to new, alright, change the text, Control X, Y, alright, so I've changed that. Now if we did, alright, notice it's pointing to the same inode on the hard drive, so it changed also. Alright, so reflection, file permissions, and ownership are two of the most important aspects of Linux. They are also a common cause of problems. A file that has wrong permissions or ownership set will not be able to will not be available to the programs that it needs to access it. In this scenario, the program will usually break and errors will be encountered. So just remember, up here we had a couple little things that were changed. The root, one of the root permissions was supposed to be set to root, not an analyst. But just kind of like bypass that, just understand what it's talking about and fill in those answers, and that is it. Thanks for watching, and I'll be making 2 more videos in a couple minutes.